Electrician Live with your host, Paul Abernathy and Jay Grunberg. Welcome everybody to another episode of, what are we? Electrician Live. My name is Paul Abernathy, your host, as always. And with me, my co-host, Mr. Basement King himself, Mr. Jay Grunberg.
What's up?
Hey, welcome. As always, another week is upon us. We made it to Thursday. We're one day away from Friday, and then the weekend is ours. How about that?
That's right, man. Got any plans this weekend?
Actually, I'm just going to the lake and chill out at the lake and do nothing but chill out at the lake. Not going to do anything else. That's all I'm doing. At all. How about yourself?
Very good.
Got anything you're doing? Any special plans? You're going to work all weekend? Going to burn the candle at both ends or what?
You know, I do enough of that. So I think this weekend I'm actually going to enjoy my best friend, Chris Lightsey. His kiddo turns, I believe, 5 or 6. So we're going to go over to his house and enjoy the birthday. So
sweet. There you go.
Birthday party.
Savor those moments. Absolutely. Well, welcome everybody. Tonight we're going to have a great show for you. Going to cover some good topics tonight. As you can probably see already in the middle of the screen, we're going to be talking about terminal limitations and all those things associated with that, and answer all those questions that are pressing about terminal limitations, conductors, and the weakest link theory. All that kind of stuff is going to be answered. Don't worry, we're going to cover it all, and we're even going to look at the Code Turd of the week as well at the end of the show, so make sure you hang around for that. So Jay, who do we got? We've got some shout outs, folks that are in the room. Remember, we love your shout outs. Let us know where you're from. Let us know you're in the house. We love to hear it. So Jay, what do we got going on?
Yep. O's in the house.
O's in the house.
O?
There you go. Thank you, O. Thanks for coming.
Diego Rodriguez is in the house. What's up, Diego?
There you go. Thank you, Diego.
Robert Solis from San Antonio, kind of probably closer to your neck of the woods.
Right here, right down the road, couple hours, 6 hours, maybe, something like that, 5.5, something like that.
Matt, wiring guru from A to Z. From A to Z. Actually, I worked for a contractor called A to Z. Mm-hmm. And they did everything but A to Z. So, anywho, let's forget about it.
All I did was F for fail. That's all they did.
F. It was a big F. But Matt's in the house. And also, Matt, we appreciate you going over to the SparkyHub.com and checking us out on that platform as well. So,
if y'all haven't done that, you make sure, again, we're trying to. And if you haven't read a lot of my posts lately, which we'll discuss some of those things because I like to keep you up to date. But because, again, I like to stomp the rumor mills. But if you haven't joined the Sparky Hub, we're trying to get away from our social media platforms. Again, we'd like you to come to the Sparky Hub and ask your questions and chime in there and create that community. We want to create a friendly, fair, easy place to post and not get ridiculed, belittled. Every question is open game. And people know I'll take any questions on any topic at any time and do my best to explain it to you, the best that I can do it. So don't be afraid to go there and post those questions. Of course, you can go to Ask Paul at paulabernathy.com as well and submit questions on that platform as well. Now, Jay, before we get started and get deep into anything else, I guess we got to run the sponsor. And so Electrician Pride is our sponsor for this episode. And so that's where you get all the good swag like this hat right here. So I'm going to run that commercial and then we'll get into tonight's topic. Today's show is sponsored by electricianpride.com, your one-stop shop for electrician-specific t-shirts, hoodies, phone cases, mugs, die-cut stickers, leggings, and so much more. Featuring unique designs for electricians, journeymen, and master electricians, as well as electrical engineers and electrical inspectors. For more information on all the products that are available, visit us at www.electricianpride.com today. Sweet. All right, so get over there and get you some swag. Hey, did you know, Jay?
For sure.
Did you know that we're probably the only live electrically dedicated show anywhere weekly? Been doing it now for over a year and a half. What do you think?
Yeah, and I'm so proud of us for being consistent. I do see other platforms periodically put out live content, but again, it's just live when they're able to do it. Whereas then we come
live
every week.
Oh, you mean the quick feeds like from the Instagram lives and things like that? That's not
exactly.
formal, man. That's not. Yeah, you're right. It's not consistent.
No, but I'm saying that there are other ones that again are trying to probably compete or trying to catch up, but they're nowhere close to where we're at. We come to you guys live and direct every Thursday. We've been consistent for a year and a half now, and obviously with you guys, you've seen the growth. And our biggest thing is just to be able to communicate and have that relationship with each one of you to let you guys know, hey man, we're all in the trade together and we're here for you. That doesn't matter if you're an apprentice, if you're a girl or guy, if you're a master electrician, a journeyman, electrical contractor, we want to be able to connect with each and every one of you and just to have that great electrical brotherhood that we have. So
and sisterhood.
I love it.
We don't offend nobody, guys. I'm known to do that. So, but always remember, folks, you can send emails to both Jay and myself at host, H-O-S-T, or hosts with an S, H-O-S-T-S, at electricianlive.com, and we will get those comments. We will get those suggestions for future shows. You got somebody that would want to be a guest on the show. All those type of things, please feel free to reach out to us. You can, I think Jay has put up on the screen the email address. You can always, of course, I probably got like 50 different ways to reach out to me. So it's whether you get me on Ask Paul or Master the NEC or Electrical Code Academy or whatever. There's always a way you can get out to us. But again, check it out, get out to us, visit all those platforms, and definitely keep checking out Electrician Live for updated information. We got a bunch of new shows coming out. I probably have been lazy and haven't updated that, but we have some great shows, and I will get it updated, but I keep saying that. But go ahead.
So we have Aaron Lohr in the house. He is actually from Denver, Colorado. That's my brother. He even says he's not an electrician, but he loves to learn from us. So that tells you even guys that aren't even in the trade are reaching out to us.
He loves his brother too. So there you go.
He does, man. He's a big supporter. On the Facebook side, we have David Englehart.
David.
So far, I'm tracking that one, David.
Yeah,
what's up, man?
We haven't figured out how to get them over here yet, and the people that do this platform that I use, I have not been able to adequately get that so that I can have both on the screen. But it's still on that wish list, but we monitor it. So again, Dave, thanks for joining. Most certainly, definitely. So we just recently started doing multiple platforms. So, and we might even expand to others as well. But this is our main platform. So, also we shouldn't forget those over on the podcast, Jay. We never want to forget our podcast listeners over at electricianlive.com, as well as on Spotify, Spreaker, Deezer, iHeartRadio, Apple Podcast, Google Podcast, however you listen. Through the website itself. You can obviously listen through the website directly at electricianlive.com or at electricalcodeacademy.com net or org. Feel free to listen there as well if you just want to hear us chatter and you don't want to look at any images or anything. That's totally up to you. Totally up to you.
That's right.
All right, so let's kind of get into tonight's topic here. So I am pretty sure, Jay, that the image that's on the middle of the screen between me and Jay here is way too small for you folks to see. I get it. But what we're going to be talking about tonight is terminal limitations, and I'm going to try to cover some things when it comes to terminal limitations to answer some questions that people have had through the years. And this illustration is one that I shared over on our Facebook page. And more I will start sharing more of this actually over on our Sparky Hub. rather than on the Facebook page, but the thesparkyhub.com. So www.thesparkyhub.com. Make sure you subscribe and get on over there. Then we're going to have this different graphics, different illustrations to try to hammer home lessons and help you learn. So I guess before I get in that, I also should get rid of what I said. I was going to get rid of the rumor mill. So as you might know, over on our YouTube channel, this YouTube channel, all of the public videos that I do in the public domain, majority of them will be pulled off and they'll be over in an exclusive area at Electrical Code Academy. I am, again, not about doing a lot of the free educational stuff, even though I've done it for over 30 years. Again, a lot of the educational content we want to keep over on our side so that we can offer an expanded offering. And so we have a subscription plan that you can do for $9.99 a month. You get access to all of our videos, all of our podcasts, exclusive content, even some of the new stuff that we've got coming, as well as access to our Wednesday night sessions where we answer code questions and look at the Fast Tracks program. So there's a bunch of things. And again, I just mention it because we'll have something that explains everything. But people want to know, are we shutting down our YouTube? And no, we're not. It's just that it's going to be used mainly for marketing aspects of it. And then we're using it as a storage repository for our videos and our podcasts. But they're going to be available over on Electrical Code Academy. And so all of those that are VIP in general, many of them have already started to transition over. And we appreciate that. So, but you'll always get the Electrician Live stuff, and you'll also get the Ask Paul stuff. Those podcasts will remain there. It's just more the video stuff that we have planned to make and expand. That's going to be exclusive content, as it should be. If you want free information, there's tons of it out there. There's only so much I can give. We are a corporation. So I know I got the people that'll hate that, but again, it is what it is. So, but it's not.
Yeah. And I think with that deal, you're also offering the 2020 analysis of the code, the new code.
Oh, the code itself.
Code changes. Yeah. For the code itself. And that's what I, before I even joined Electrician Live as a co-host with you, I was involved in the Fast Tracks program. And I got about halfway through the Fast Tracks on the 2017 when the 2020 was being offered. Mm-hmm. So I ended up switching gears over to the 2020. I bought the 2020 bundle package. Again, call me a NEC geek freak, whatever you want to call me, but I can tell you that I've had more intelligent conversations with electrical inspectors than I've ever had. And just by that content that you provide for that $9.99, and to be able to go in and brush up on the code changes, I'm able to highlight in my book, bring this book with me. When I say book, this document here, the 2020 code.
And that one's beat to death, mind you.
Oh man, I tell you what, I show up on the job site with this. A lot of inspectors really respect that. And again, it's like almost like we're on the same sine wave with them. It seems like when I show up with the code book, because they're like, some of them tighten up. They're like, oh no, is this guy gonna, is he gonna? Well,
I'm not gonna take what you. I'm not gonna take. Just tell me. I'm gonna make you prove it, right? I'm gonna say, well, let's look that up together. So
that's right.
That's awesome. So again, wasn't a commercial for our programs, but there was a lot of people that were asking questions about some of the posts that I put out. And also I took some heat on the Facebook page for posting a non-made in America tool. And, one guy said, you should rip your page down because you don't support Buy America. Look, dude, I can guarantee you the TV you're watching, the phone you're using, the car you're driving, all of them have components that are made outside of America. Okay. I worry about the hardworking electricians out there who need to make money. Now, if you want to buy Nipex or Nipex or whatever you call, they're made in Germany. Okay. A lot of the products that are made by other tool manufacturers are not made in the U.S. They might be assembled in the U.S., but they're not made in the U.S. I'll have you know Harbor Freight is a U.S. company that helps support payroll and pays taxes into this economy. Okay. So that they do that. So when somebody hits me with, you don't buy American, dude, go look in your closet, the shirt you wear, the stuff you've probably made in Malaysia. Okay. So if you want to be all made in America, everything, stop being a hypocrite. Stop buying anything from any other country and only buy American. And when you have to go to work naked with your boxers on that you hope are made in America, they're okay. But don't give me this. I get so tired of that BS, okay? What? You're promoting something from a product that's made in China. Yeah, okay. My wife's car is a Kia, okay? My Ford truck has a chip in it from China. The TVs I've got, the Samsungs, they're made in China. Get over it, okay? There's many ways to support America other than spouting that BS. Anyway, there you go. I vented that live. How about that?
That's right. That's right.
Sorry about that.
Great, man.
So that shows you I do read your posts on there. So Rombo's in the house.
Yeah.
It's been a while. Haven't seen you in a while, Rombo. Thanks for coming.
Rombo.
He's a busy
Elwood
guy.
in the house.
Elwood. There you go. All right. I'm sorry.
Humble. He says he loves the podcast and he loves the facts and the good quality. So keep it up. Again, this may be his first time actually chiming in on the comment section, but sounds like he's more of a podcast guy. So we appreciate you coming over and joining us on the live stream. And again, guys, if you have questions, we're going to get into the terminal limitations in 110.14c, and we're going to go over it. If you guys have any questions while we're going over it, please put them in the chat. I know sometimes it's hard to ask questions in the chat, but just keep it short, simple, to the point, and we'll get to you guys for sure.
Absolutely.
Tim,
Code Strong's in the house. House. And Tim's gone through there, man. Tim's taken all these exams in our fast track so many times that I'm like, dude, you ought to just memorize everything in the program. So, but he's hammering at it, getting those licenses in multiple states. There you go. So
good for you, Tim.
Good job. All right, so let's go on, and I'm going to go to the code, guys, so we can look at the code. So what we're going to be talking about is terminal limitations, and I'm going to kind of explain, and Jay chime in, and I got the gift of gab on these things. So anything you want to say, just jump it right out there. So hopefully you can see what we're looking at here. So I'm going to. Oh, wrong page. Sorry. I'm looking at analytics. How about that? Better page? Okay, that's better. You don't need to see my analytics. All right, so what we're looking at is 110.14c1, and we're looking at C1A and C1B. So this is a question that everybody always asks me when we're doing ampacity, and I make this comment about after adjustment and corrections. Let's say you're doing it from the 90 degree and you're making adjustment and corrections in accordance with 310.15 B2A or B3A in the 2017, or 310.15B or 310.15C in the 2020. If you're making adjustment and corrections, they always, at the end of the day, as long as you don't exceed the terminal limitations. So you always have to take terminal limitations into consideration, obviously. So it's better for us to understand this. So we'll kind of look at it from the top, and I'll explain it as we go down. Again, you can see the chat on the screen. If you got a question, you'll have more than enough time to type that out. And we'll do our best to translate. And if there's anything on Facebook, I assume that Jay will monitor, or if he can check that out, because, again, I don't have the luxury of that up here. So, all right, so let's look at 110.14c1, equipment provisions. The determination of terminal provisions of equipment shall be based on 110.14c1a or c1b. Now, the first thing to remember is we're going to do something we call the power of or. If you ever see and in the code, then it means this and that. When you see or, it means it has to comply with this or that. Okay? So in this case, depending on your situation, you might have to comply with 110.14c1a, or you might have to comply with 110.14c1b. So it's an or in there, either or. Now, in this case, chances are you're going to be in either one or the other, depending on either your conductor size or dealing with the level of ampacity we're dealing with, right? So it says, also carrying on, it says, unless the equipment is listed. Now, this is important. It says that you follow it based on 110.14c1a or c1b. But here's where people lose a little bit. It says, unless the equipment is listed and marked otherwise. Conductors and ampacities used in determining equipment termination provisions shall be based on table 310.16, which used to be 310.15b16 for those that are in the 2017 code, as appropriately modified by 310.12, which if you're in the 2017, that would have said 310.15b7. Okay, same thing, just changed for the 2020 code and moved it around. Okay, what's important here is a lot of times you're going to have, before I get this out of the way, a lot of times you're going to have equipment, and let's use it simple. Let's say I have a circuit breaker and I have a receptacle at the other end. Okay, so the terminals of the circuit breaker are going to have a rating, and the receptacle is going to have a rating at their terminals on the other end. Okay, so in a perfect world, we know what those are. We know that this is either a 60 or 75, and on that end, it's either 60 or 75 generally. Okay, so in a perfect world, we know this. So if I have equipment where the terminals say 75 degrees C, and what I'm doing is I'm paraphrasing first before we get deep into it, is if the terminals at the breaker are rated 75 degrees C, and the terminal on the receptacle is rated 75 degrees C, and as long as my insulation on my conductor is at least 75 degrees C or greater, then basically I can use the 75 degrees C. Because, why? Because the equipment is listed and marked otherwise. So what's important with A and B here is you run into situations where nothing's marked. The terminal's not marked. Or one of the terminals, let's say at the breaker's not marked because it's an old breaker, but you know a terminal at the receptacle's marked. So maybe it's marked 75. But you get back to the actual breaker and you can't tell what it is. But what you can tell is that it is 100 amperes or less, and you can tell the size of the conductor is 14 through 1. So when you're using 110.14c1 in the real world, if something's not there to give you the listing and marking otherwise, as it says in the charging statement, then you have to go with the weakest link. And that is, if I looked at an installation and I couldn't tell what the terminals were on the breaker, but I could see the receptacle and it said 75 degrees C rated, okay, and I use 75 degrees C rated insulation, the fact that I cannot tell what the terminal is for the breaker creates what we call the weakest link. And because we can't tell, then the fact that that insulation is rated 75 or greater and that terminal at the receptacle is rated 75 is irrelevant. We're going to have to go with the rules as it's written right here. And since we don't know what that breaker's terminal is, but we do know the size of the conductor on it, and we do know what the ampacity is on it based on the marking on the breaker, because the rating of the amperes on the breaker sets the tone for the circuit rating. Okay, so at the end of the day, we're going to have to follow the 60-degree ampacity values in table 310.16 as it says in the charging statement. Okay, so are we so far good, Jay?
So far, so good.
Okay, so let's look at 110.14c1a. It says, terminal provisions of equipment for circuits rated 100 amperes or less, or marked, notice it says or, marked for 14 AWG through 1 AWG conductors shall be used only for one of the following. So you have options here, okay? And it's basically going to revolve around what I elaborated previously, okay? So if I don't know what the terminations are, I don't know what they're marked otherwise, then I'm always going to use A1, which is conductors rated 60 degrees C for ampacity purposes, okay? So in this case, if it's 100 amperes or less, remember, I don't know what the terminals are because they're not marked or they're old and I can't tell. All new stuff's going to be marked, don't worry, but old stuff, for exam, again, there's an exam world and there's a real world. In the exam world, they can make up anything and have you answer the question. In the real world, you're either looking for markings or it's not. And if it's not marked, then you go with the weakest link theory. And again, that's what's going to be the weakest link. So in this case right here, if we had a situation where it's 100 amperes or less and the terminal wasn't marked, and if the conductor fell in the 14 through 1 gauge category, okay, then if that's the case, then we would use a 60-degree rating. Make sense?
Right.
And that's the ampacity of that conductor. Now, keep in mind that non-metallic sheath cable, for example, in 334.80 is going to be limited to 60 anyway because that's the requirement there. Any other thing that we're talking about here is not to do with the cable assembly. This is like if I'm running THHN, THWN-2 or XHHW-2 and pulling it in a raceway, yada, yada, those type of scenarios. Okay, so you got to follow all the other rules in the code, but we're just specifically talking about terminal limitations as we have it here. Okay?
Right.
So the next thing is A2. Now, A2 says, okay, look, I can use a conductor with a higher temperature rating, provided the ampacity of such conductor is determined based on the 60 degrees C ampacity of the conductor size used. Now, remember, this is only saying, guess what? I still don't know what the terminals are rated. But because we use modern wire today, I want to use a conductor that's rated for 75. Don't nobody use 60-degree rated wire anymore, other than what's rated in a non-metallic sheath cable. And in that case, it's still rated 90 for adjustment and corrections. We just are limited to 60. So at the end of the day, this rule is saying, hey, Jay, I know you don't know what the terminal ratings are, but if you want to run 75 degree C rated insulation or 90 degree rated THHN, you're okay. But remember, because we don't know what these terminals are, you're still going to use the ampacity for 60. Right?
Correct.
Okay, so that's the second one. That's how we follow that. And I saw your flickering camera, but I didn't know what you did. I thought you were sending me Morse code or something.
No, I didn't know what was going on. So, I guess would this be also with this allowance in what is it C A or C1 A2 with the conductor with higher temperature ratings? So let's say I'm doing a 50 amp remote distribution panel or a sub panel down in the basement, a subby, bro. And I know,
well, 50 is pretty darn low. So, but okay.
Well, let's say normally I run a number 6 SCR cable. And let's say the supply house says, well, we don't have number 6, but we can give you number 4, which is obviously a higher ampacity.
Yeah, it's larger
conductor. So it's a larger one. Is this the allowance that tells me that I can use that number 4 in this application?
So no. So this is saying this is based on a temperature rating of the insulation. Okay. So if you use a 4, then you can use whatever the ampacity is at 60 degrees for the 4 if you want. So what this rule is just saying that, Jay, I'm going to let you use a conductor with a higher temperature rating. As long as you remember that you still are limited by the terminals to 60 degree, I'll let you use that THHN if you want, but you can't use the ampacity for a 90 degree rated under the column 31016. Okay, if you go up in a bigger conductor size, then you can most certainly use the ampacity of that number 4 if you want. Okay, so this has to do with the temperature rate. So this is about the insulation rating. Okay. So this allows me to use the 75 or 90 degree rated, but because I don't know what my terminals are, because I don't know what those are, then those are the weak link. I'm still limited to 60 degree, okay, as far as ampacity.
Gotcha.
Yeah, you can use that 75 or 90 degree, but it's still limited to 60 ampacity under the 60 degree column, okay? So that's what 2 is all about.
Gotcha.
All right, so 110.14C1A3. Now, this is the one we use the most, and this kind of correlates with the charging statement. It says conductors with a higher temperature rating if the equipment is listed and identified for use with such conductors. So I can use a higher temperature rating. I can use a 75 degrees C rated insulation, even if it's 14 through 1, even if it's 100 amps or less. And if all of the terminals are marked 75 degrees C, then guess what? I can use the ampacity from 75 degrees C. So I can ignore the fact that it's 14 through 1. It could be a 12 gauge, for example, right? And it's obviously going to be less than 100 amperes. But can I use the ampacity at 75 degrees C? And the answer is yes, because all the terminals are rated at 75 and my conductor's insulation rating is 75. Okay. And it also could be 90. Now we know that we use 90 for adjustment and correction purposes, but at the end of the day, this is just giving us, this is kind of backing up what's in the charging statement. Because here, again, as long as it's listed and identified for the use with such conductors, again, used for a 75 degree rated conductor, then you're okay. All right. So that's the kind of concept that we're dealing with. Okay. So
well, that goes back to my example before where I was where we have a main service, the main panel at the residence, and we put in a breaker. Let's say it's a 2-pole 50, and on that breaker it says terminal limitations 60 / 75.
I can use the 75.
You've seen that, so it's multi. It can be used for both.
Yep.
So okay, now my breaker is that. Now that's my starting point. So I know that this breaker terminal limitations allows me to go up to the 75. Okay, cool. Well, again, under the 310.14C1A, it says anything that's less than 100 amps. Well, we're at 50 amps, but it's okay because the terminals are rated for 75. So then I go to my next step and I go, okay, the SCR cable that I'm running, the insulation on that conductor allows me to use that at the 75. So now I have the beginning point, my A point, my starting point at the main breaker.
You got the breaker, you got 75. The insulation rating. Now you got to go to the end.
Insulation rating. Now I have to go to the end, and that's where I have the remote distribution panel, and I open that guy up, and the main lugs on there, they say that they're rated for 60 or 75. So this is an example where we can use a 75 and actually install a smaller conductor in some areas because we're able to use that 75.
Yeah, because the conductor will have will have a higher ampacity rating on it than it would if it was under 60. Right. Just remember, so cool. I always ask this question for people as well. It says, well, what if my breaker is 75, but my receptacle or your panel, for example, I'm using as bad example because all of those lugs in a panel are going to be 75. But what if my lug at the other end was only rated 60? Just because my wire is 75 and my breaker's rated 75, if the receptacle, or in your case, the panel, if that was only rated 60, then 60 is the weakest link, and I'm stuck at the 60-degree column for ampacity. You with me? That is the totally weakest link. Okay? All right, so, and this is the general charging statement where it says, unless equipment is listed and marked otherwise, in conjunction with 110.14C1A3 is what we tend to use to allow us to take, for example, those 12 gauges, those 14s, those 10s, and be able to use it at the 75 degree, unless it's something like a non-metallic sheath cable, which is already going to have a preset reduction on it. Now, you mentioned SE cable. Just remember, under Article 338, there is also a limitation in there. And that limitation is for 10 gauge and smaller, that you're going to be limited to the 60, just like it would be a non-metallic sheath cable. Over that, then you can treat it at 75 or whatever the rating is of the cable assembly. So don't lose sight of that. There's all those little nuances that have to do with the cable assembly. So when I teach people this, I tell them, make sure you go and read what the limitations are of the product cable itself, right? Once you establish its limitations, then and only then you get to see whether or not 110.14C1 is the driver, or if you're dealing with individual conductors in a raceway and things like that, then you can jump right to your terminal limitations of 110.14C and follow it accordingly. But always look for that weak link, right? So the last one with A is, it goes 110.14C1A, item number 4. And that is dealing, it says, look, for motors marked with the design letter B, C, or D. Now remember, this is saying, look, the terminal limitations are generally 100 amps or less, or marked 14 through 1 conductors have to use one of the others, okay? So if I use item number 4, it is saying that if the motor is marked with the design letter B, C, and D, and those that are studying for an electrical exam, remember that, okay? Because those questions tend to come up on exams quite a bit, and they will give you typically the design letter B for high efficiency motor. I believe that's what that is. So, any rate, it says conductors having an insulation rating of 75 degrees C or higher, and higher would be 90, that type of thing. And there's some applications where it could even be higher than that, like a 105 for machine tool wire, things like that. But it says for conductors having an insulation rated 75 degrees C or higher shall be permitted to be used, provided the ampacity of such conductors does not exceed the 75 degrees C ampacity. So what this is saying is ignore the 100 amps or less Ignore the 14 through 1. If I'm dealing with the design B, C, or D motor with an insulation rating on the conductors of 75 degrees C or higher, I am permitted to use the 75 degrees C ampacity value as long as I don't exceed that, right? So other than that, other than these designs, you follow the general rule here based on 14 through 1 or 100 amps or less. Okay. So this is just giving you an allowance for these type of motors, for this type of design to be able to do that. Okay. Now, I will tell people to be careful, because even when you might have this situation where the motor is marked design letter B, C, or D, but typically their terminals are going to be rated 75 degrees C, don't lose sight that there's another end of that conductor that gets terminated onto something that might still be a weak link. I don't care what this rule says. If my breaker is only rated for 60 degrees, then I got a problem. Okay. It's just the termination to this motor, these motors that are allowed to be at 75. So don't forget, this doesn't give you that carte blanche to do anything you want. You know, this is very specific. Okay. So that's how 110.14C1A works. Okay. So when somebody says to me, I don't know what the breaker is, or I don't know what the rating of the terminal is, then you simply follow this rule. And if it is 14 through 1, 60 degree ampacity. If it's 100 amps or less, and you don't know the conductor size, but you know the ampacity, still, if it's 100 amps or less, then you're going to be 60 degree. That's it. If it's marked and listed at a rating higher than 60, like 75, then you're okay to use a conductor with a 75 degree C rating or higher, and you can use the ampacity under the 75. Okay? All right, makes sense?
Makes sense.
All right, so now let's go on to 110.14C1B. Now, obviously, there's less numbers here. So terminal provisions for equipment for circuits rated over 100 amperes or marked for conductors larger than 1 gauge shall be used only for one of the following. Now, obviously, we do ampacity values in 60 or 75. So people ask me, How come 90 is not listed here? Because 310.15 tells me that I can use the 90 degree ampacity for adjustment and correction purposes, as long as at the end of the day, after those adjustment and corrections, that my actual load does not exceed the terminal limitations, which are either 60 or 75, and that's going to correspond with the ampacity value that's in 310.16. So as long as after adjustment and correction, I still got a conductor that can handle the load, and that load doesn't exceed the values that are in the 310.16 ampacity table, then I'm good to go. Now, when can you use a 90? And when can you use that ampacity? For real. Not just for adjustment and corrections, but for real. If you have, usually the reason that we're limited on breakers is because of the breaker manufacturers, the limitation for the terminal, okay, heat and things that they do as part of their testing. But you can go from bus to bus where they are rated for 90 and get away with the ampacity value for 90. If you're going like a bus to bus, something like that, where the terminals on each end are actually rated for 90. Just remember that when you're going from that bus back down to something that has a limitation on it, like a breaker, that you have to make sure that at least from that point up to that terminal that's rated 90, that it is designed to handle the ampacity. So you just got to be careful in your installation. Majority of what you're going to run into are not going to be rated 90. You would do adjustment and corrections from 90,
right? But
they're not going to be rated 90. And the second one, so you're going to use for all cases when you're dealing with, again, larger than 1 gauge and over 100 amperes, then you're going to use 75 degrees C and the ampacity. That's what you would use. Okay? Just pull straight from the table if that's what you – if there's no adjustment and corrections to do, you just pull straight from the table. That's it. Okay? If you have a continuous load, again, you know that you're going to have to take that load at 125% and then just simply pull from the table. So depending on your condition. And there's rules. I should mention that we have a video called Derating Demystified that goes over all these things. Again, I should also say that that's no longer available for free. It's only available in our subscription program. I know I got, hold on. I got a button for that because I know that I'm gonna get people. They're going to say, hold on. Too bad. You've had it for free for 30 years. All right. So the number 2 here is 110.14C1B2. That's basically saying conductors with a higher temperature rating, let's say a 90, can be used provided the ampacity of such conductors does not exceed the 75 ampacity of the conductor size used, or up to the ampacity if the equipment is listed and identified for use with a such conductor, which is basically what I just described. If all the equipment's rated for 90 degrees C, then I can use the rating at 90 degrees C, and that's what the allowance is in 110.14C1B2. Okay? All right? So that's what has to do with terminal limitations. Do you have any questions? I mean, I knew it would be a pretty straightforward thing, but it seems to cause a lot of people confusion. So, Jay, you're an electrical contractor. I'm getting ready to end mine. Most people know I'm also an electrical contractor there, but I'm getting ready to cancel that. I'm just not going to get out in the field anymore. So, I know that shocks you, doesn't it, Jay? That
that's right. That's right. I thought you're a real electrician, but apparently you're throwing that away.
Throwing it away.
No, I really think that understanding. I think this is I guess an article that people don't fully understand, or I guess what I'm saying is when apprentices or even residential wiremen, journeymans, when they're running the cable or the conductors through the raceway from either the overcurrent protection device, the breaker, to either another piece of equipment like remote distribution panel or even a receptacle. Let's say it's for a X-ray machine, something that's higher than 100, or maybe it's even less than 100, but it's still rated at the 75. It can do either 60 or 75. I really think that the actual installer is installing it per the plans or per what their boss is telling them. But really, if you just go to this section right here, you can actually understand it fully of the reason why you're running it. And you may even be able to save yourself a little bit of money on the size of conductors that you're running if you were to follow these rules. If the equipment is rated for the 75, if your wire or your cable is rated for the 75, and the terminal on the other end, let's say it's another piece of equipment or a receptacle of some sort, a device, and that's rated at 75, but it's under 100 amps, but all the requirements meet the 75, most likely you're gonna install a conductor that's a little bit smaller than what you would install if it was at the 60 degrees. So really, you're able to save your company a little bit of money, or even yourself a little bit of money, if you actually understand these rules. And it's so, we say it's so basic, but even guys that work for myself, I ask them where the terminal limitations are, and they even go, huh? What? What does that mean?
It's important to know all these things, because talk about feeders, for example, in 215, and I believe 215.2, there's an allowance to say, look, if you look at the code, it's still on the screen. If you look at 110.14C2, this talks about separate connector provisions, and many people have brought up things like Polaris splices and things like that. Mm-hmm. That's an example of a pressure connector. So there are allowances, for example, where because the breaker's limited, if I have a wireway above a panel and I'm feeding another panel downstream and that has a wireway above that panel, the allowance, and understanding the allowances in the code, that's why we study the code, because you can save money.
Yes.
Okay. And money means more money in your pocket, and also means compliance. But there's an allowance in there, for example, to go from that panel up to the wireway, and in the wireway install a splice. And if that splice is listed for the 90 degree, let's say, then I can go from that splice down to the next splice that would be in the wireway downstream. And those conductors can be sized based on a certain value, the 90 degree C, whereas you're going to be limited because they're rated for that. But from the lug down to the actual panel, then that's where you're going to be restricted. And so it gives you an allowance to be able to do that, because I might be able to run a smaller conductor from splice to splice than what I have to run from splice to box. So check that out. That is in one of the exceptions, and it's done all the time. So as long as you know how to do it. I can't see it. It's blurry. You won't be able to see it on the screen.
See it. But what I got out of that is from that initial panel to that first splice point above the panel. Let's say that's 10 feet. Let's just say it's above the grid ceiling. It's above the drop ceiling into a box that's mounted on.
And while you're talking, I will actually go to show people what I'm talking
about. And then from that splice point to all the way across the building, it could be 200, 300, 400 feet away. Obviously, you're going to have to implement voltage drop and everything like that would be effective in this. But, that 200-foot run, you're going down a cable size, one or two smaller, and that could be $50 to $1 a foot.
Sure.
And you got 250 feet. So you're saving $250 to $500. You could be saving in just a run because you understand the allowances of the code. And that's where we can save money.
So as you see on the screen, 215.2A1, the exception says where a portion of a feeder is connected at both its supply and load ends to separately installed pressure connectors as covered in 110.14C2, which we looked at. It says it shall be permitted to have an ampacity not less than the sum of the continuous loads plus the non-continuous loads. So the benefit of understanding these terminals and these rules means that I don't have to add that additional 25% for a continuous load. I can take it at 100% and 100%, whereas usually the breaker is what's limited in that. So understanding all these rules means that I might be able to go up to that with maybe 600 kc mil. But once I get there, that span to the next box, I might be able to drop down to 500 kc mil. Now, it might be smaller. You got to look at your install. But that's money. That's tangible. Okay? Now, people say, well, what about voltage drop? Well, voltage drop's not a requirement of the code. It's good engineering design. But unless it's sensitive electronic equipment and fire pumps, voltage drop we can play around a little bit with. Again, it's prudent to do it. But we're talking about some applications where if you know the code, then you can get around certain things. And so it just ends up being a beautiful thing. And I like I said, it never gets old with me, even after 32 years. It never gets old. The code is it's an awesome document, and just understanding those different things. Okay. So, all right.
Elwood says, but sometimes could mean more parts and room for error. Never really see it done in the field. I actually,
because I'm obviously work for wire and cable, I actually see Elwood done all the time in the field. Engineers consult me all the time, probably because they're worried about an error. But as long as they follow the pieces, where this really saves them is when they're running parallel runs. And parallel runs, if I can save quite a jump in size in circular mill between from point A to point B and do that over multiple conductors, then they can save money. And sometimes they're looking to try to save whatever they can save. And I'll help them if they want help.
Sure.
So that type of thing.
Oh, and it's not just the wire that you're saving on too. It could be even the size of the raceway. It could determine whether or not you're running
from a trade size 3 to a trade size 2.5 or something like that. I mean, you just never know. So it's good to be able to do this. You might just say, screw that. I'm going to make it all the same size. And that's fine. But there are things that you need to know about sizing conductors and, again, ampacities, continuous loads, non-continuous loads, how they apply. And so in 210.19 for branches, 215.2 for feeders, and 230.42 maybe for services. Understanding all of that is so critical to being a success. And we're just talking about terminal limitations. But it can be a greater picture to learn all those little things, All right. You ready here? So what we've got is we're going to now move to this segment that you all wait for, and that is, well, you guessed it, Code Turd of the Week. All right. Here's our Code Turd of the Week, supplied by Jay, and I am not sure exactly where he got this Code Turd, but it says been working real hard on bending conduit. Can I get any feedback? Okay.
Well, hold on. First of all, I don't see any bent conduit in that picture.
It's above
Maybe
the ceiling,
above.
Dude. It's up there somewhere.
Above the ceiling. All I see is straight. Well, from the picture that the person's putting on there, again, none of that tubing, or it's probably tubing. It's probably EMT. But if it is conduit.
Well, those fittings look like EMT fittings, so hopefully.
Yeah, they do. They do, don't they?
So, and let's hope they didn't paint that all the way before they put it down actually into the fitting. So, in other words, if they did, they scraped off the paint. We're not going to assume things that we don't see. But yeah, so I have some code references on the screen. But Jay, do you have anything that you want to call out?
No, I just by looking at it, obviously, I mean your violations on the screen are probably up to par. I see it.
Jay,
not
do you
being,
know? Did you know your crap hat
professional.
Do you know your crap hat has lights?
I do. I turn them on just for you
guys. Just so you know, you got lights in your turd.
I do that.
Okay.
It's a lit up turd.
It's a lit turd. All right. So
a lit turd.
Okay. So at the end of the day, maybe the guy will come back and fix this. But the look of it, the age of it, probably not. Okay, it's not going to mess with us. So, what are some of the things we see, Jay? Well, I don't know if you can see the screen, but in those, I know it's hard for you out there to probably see this. So that's why, and it's hard for us, and it's still here. Okay. First of all, there's absolutely no pride in your work. You know how I hate people that call me all the time and say, "I'm a real electrician. I bend conduit. I bend tubing all the time," and I'm like, that does not make you a, quote, real electrician. You know what?
Right.
Running something neat when it's easy, but still can be neat, can make you a savvy. Like MC cable is easy, quick. It's a listed product, but it's clearly, you can take something that's easy and still make it look like a turd. Okay? It should have been easy to make this installation look good. And it just looks like a turd. Okay, I would be embarrassed to have this, right? Okay. All right, so...
Yeah, but I can tell you, I've been on jobs, on projects that I go into, and it looks just like this. I mean, older buildings that probably, maybe it was a tenant improvement that didn't get inspected.
This isn't a wired up electrical design job, is it?
No, I'm not going to give this job credit for that. I mean... And if it was, I'm definitely not going to say it. That's for sure. But I've seen
might be a wired
installs.
Up job. I don't know.
It might be, man. I mean, look at the way that MC is intertwining. That's beautiful.
That's magical.
Yeah, that's a sine wave of electricity.
It's a sine wave. There you go. It's just sinusoidal waveform. All right, so the MC is clearly not secured and supported in accordance with Article 330, Section 30. Obviously not secured properly. It's not secured within 12 inches, obviously. None of that. Okay. And then once it's over a certain size for 4 conductors and 10 gauge, believe it or not, you can secure MC up to as far as 6 feet. So that bigger feeder type MC, when people see it and say, that's not secured within 12 inches, it wouldn't need to be if it's size larger than 10 gauge with 4 conductors in it, then it would be, you could go up to the 6 feet. So it's not always 12. But this is small, so this is going to be within 12 inches, and it's not, obviously. And chances are it's not secured within 6 feet of the next support up there in the ceiling. I'm pretty sure it's probably not. It just looks like a spaghetti mess. So that's a violation. The next violation would be, obviously, it's hard for people to see it. And obviously, if you're over on the podcast, you're just hearing us talk about it. But they're securing MC to a raceway. Now, on the surface, people go, what's the big deal? What's the big deal? Well, the fact that the code says you can't do it's one thing. But where's the big deal? Well, in this case, everything's running vertical, so it's probably not that big a deal. What becomes a big deal is when they do this, a bigger deal, I should say, is when they do this horizontally. Because the fittings, associated fittings, are designed not to support added weight. And the more you start connecting onto it, these cables have weight, right? So that would be an issue, but it's irrelevant to vertical or horizontal. It's still not allowed per the NEC. The next thing that we see in here is there are cables that are actually secured to cables. And that is also a violation of 300.11d. So C is for the raceways used as support unless they're listed accordingly as a support method. But of course, cables being secured to other cables. And where people also make this mistake, Jay, is I've seen people put MC, strap it properly, and then come along and take additional MCs and strap it to the MC. And that would still be a violation of 300.11d because you're supporting. Now, the easiest way around that is make sure that you make the connection to the actual clamp or securing or supporting method that you're dealing with. Okay. So that would be, but I'm thinking there's got some MC supporting MC, and there's this type of stuff, kind of wonky stuff going on. Now, what I can't see is, but I believe there's some EMT running in there that's got a bit of an offset on it, kick right there in the middle between the A and B. It looks like EMT that is not secured within 3 feet in accordance with 358.30a. Maybe it is. I just can't really see it, and my eyes are getting old, and I can't see it. That middle one, I don't know that I see it anywhere. I see a coupling, but I don't know that I see a securement.
No, right above it, I have the picture on my phone. I blew it up, and I think that's the piece of tubing that guy's probably talking about that he's been working on it, because everything else looks pretty much existing except for that new piece of shiny EMT that he put we call that like a rolling offset, because it starts at one point, and instead of just offsetting up into a box or over an obstacle, he actually is coming out at one position and then offsetting, but also roll offset because it's rolling to a different position as well. So that looks like a rolling offset to a set screw coupling, and then probably maybe 4 inches above that set screw coupling, there's a support.
Okay, so here's where the haters in the world come out of the woodwork. They'll say, hey, bro, you're working on a bend, but you had to do an offset and put a coupling within a foot of it. I would expect you to do that rolling offset with a full piece of EMT that goes all the way up into the. Why did you need that coupling? Me, I don't care. Whatever gets the job done. People will actually get all serious about that, on jobs, and like, well, I wouldn't do that crap. Okay. But I'm saying it's still compliant. And again, mechanical workmanship and neatness is all in the eye of the beholder. It's coupling looks fine. I'm just saying some people would say, oh, you obviously couldn't make that offset. So that's why it's only you cut off the excess so that you could do this because whatever. But okay. So that's why I said maybe, because I can't see. So the next one's 110.12 mechanical execution of work. I don't know that I call that a maybe, because that looks like turd work there. So obviously it lives up to its name, turd. And there was no professionalism and anything in it. Now, the NEC tells us to have to do something in neat and workmanlike, but that's about as far as it goes. Then it has an A, a B, and a C. Okay. Talks about missing knockouts and things like that. But, NECA does have a document that gives some guidance on neat and workmanlike, right? So, but I've never really seen too many electrical. So for example, this one I could actually cite 110.12, and if somebody said, well, how could you do that? Neatness is an eye of the beholder. There is, since he's not securing it, since they're not securing it and supporting it, then that is nowhere near compliant. So this is obviously also not in neat and workmanlike as well, because you're not securing it and supporting, and you're just bringing them all together. It looks like a rat nest. So I could cite 110.12 and get away with it. And of course, new for the 2020 code is given all those references following the building surface and all that under 110.12c as well. Since that is not secured to the building surface, it looks like most of those just go up into a little converging area, which is what I call the nesting point, and nothing's secure. So it doesn't meet any of those rules. You folks out there might see other ones, but that's what I see. And the only other violation that I will tell you is a moral violation. That guy's not using Encore Wire MC. Shame on him. He needs to be using that.
Shame on him.
Yeah, there you go. All right.
And from again, this is outside of code. But when I was running tubing and even MC cable, we would, if you look at the supports that they do have from left to right on the conduit or tubing, whatever that is, it looks like on the far left it's a 1-hole strap. Next to it is a mini. And then you jump to the other side and you have a 1-hole strap on the smaller, maybe that's a 1-inch. And then there's a 1/2 inch that has a 1-hole strap. And then on the, I don't know if that's a 2-inch or whatnot, the bigger tubing, it has another 1-hole. And they're all at different positions. They're all different levels.
Dude, whatever he had in the truck, he's like grabbed whatever he had and just slapped it up there.
That was not, as far as the coupling goes in such a short span, that's okay. I've seen guys that will try to spend 2 hours to make 1 or 2 bends on a 10-foot stick, that perfect bend. And to be honest with you, they get so frustrated, they're just like, I'm going to put it up anyways. Or they cut it and they coupling it and they move on. Well, guess what? You could have saved that hour and a half of time by just taking that darn coupling and putting it in there.
Have you ever watched looked at those pictures over on the Instagrams and all that have all this conduit that's just beautiful? And you got to wonder,
oh yeah,
is that the employee or did the owner do that? Because if I'm the owner, I'm thinking that is beautiful. How long did you spend doing that and making it look perfect? I mean, I'm just saying, because at the end of the day, it is craftsman. It looks good. But there's always that debate versus a raceway versus a cable assembly. And if you're in Chicago, you're like, oh no, it can only be raceway. Can only be. And if you're anywhere else, they're like, I don't care. They're both listed products. So at the end of the day, it doesn't matter. There's no need to install the garbage like this. Okay? You can install it right and be able to do this right. There's plenty of space between that center and to the left that they could have put, they could have mounted a Kindorf or something on it. They could have done something in order to make this look much neater. Boy, your camera does flicker. Boy, how many of you out there think he shouldn't invest in a higher quality camera? I'm just saying, or is it the one I told him to get? Never mind.
It's the built-in camera. That's what I don't understand. I'm wondering if it's just not syncing up with the software tonight. I have no idea. We
have to get you an external camera. You got to get rid of the built-in camera.
Yeah, I know. I do. I just haven't set it up yet.
90s or whatever. Okay. All right. Anyway, we're working on him. The Basement King. Also, I should announce this, everybody. Congratulations to as me and Jay work more and more together on some things and projects we got going on. He is an official premier affiliate with us. And again, go to thebasementking.net and check out it. Again, it's all our products, but again, it's through Jay, and it helps support Jay. And again, welcome as always, and we'll be doing a lot more things together in the future as well. And, all of us older guys have to have people to take over. So, the next generation have to, the Pauls die, the Jays live on. There you go. So he's young.
Well, we're as a part of the affiliation, a part of Electrical Code Academy. It's definitely an honor to be a part of that with you and to actually look forward to what we're going to build. And with that, I think that's why you made that decision to have that subscription, because we're actually going to take a lot of our time, our personal time to filming. And again, these are not how-to films. These are educational films. These videos that we're producing will relate to the programs that we're offering you guys for training. So it's such a great honor to collab with you and to be a part of it. And I just can't tell you, I don't even know what the future is going to hold. And I just know it's great, and it's going to be very, very rewarding when multiple people like yourself, you've had people that come up to you and they congratulate you for your leadership, your training, because they pass an exam. And that's one thing that I haven't had that privilege yet. And that's something that I'm gonna look forward to with this training and the educating and being a part of Electrical Code Academy. On a personal note, I did have a guy reach out to me on Instagram today who is part of the Fast Tracks program. I won't say his name, but he asked me, he said, Jay, do you do one-on-one tutoring? And I don't do one-on-one tutoring. That's something I don't do as of yet. Maybe in the future, I may, if it's through the academy and we can make something happen, maybe that's something down the line. So for anybody out there that wants to get a hold of me for tutoring, I don't do it. I do know this individual, so I did tell him that I would have a one-on-one session with him where we're going to dive into the code together. But again, I don't know how much he's going to benefit from it or if it's even going to help him at all. I'm pretty sure we can come up with something, but that's really not my strong point as of right now.
Now, remember, folks, if you're in the Fast Tracks program, everything, and I've been doing this for over 30 years, everything that you need to know to pass an exam from the NEC portion is in that program. Now, if you're reading it and you're not comprehending the material, that's the reason why we don't have nothing but we don't just do videos on it. I am a big believer, and you've heard me say this. You have to read it to be able to comprehend it so that you understand it. Okay? Remember, you have to read it to comprehend it, to understand it. That's why it's that way. Yeah. I don't get around just doing videos because you'll go to sleep. You won't look up things. You won't be interactive with it. If you get a poor review from me, then you need to go do the unit. Take your time. This is not a race. And also remember, you're in the Fast Tracks program. There are many ways that you can reach out to me if there's something you don't understand. Email me. There is no dumb question. It's just a question that you need answered. And probably you're not the only one. So we want to make sure that people get the information. Again, that is what I do. And I've been teaching people right now. The upwards, the last we checked was over 40,000 students that I have taught since 1989. So that's what we're here for. That's why I created the Fast Tracks program. It's like no other program. It has a lot of reading. Yep. It's a lot of stuff you have to do on your own. Yep. But I'm here. If you need me, don't be afraid to ask me any question that you want. That's what I'm here for. Now, the reason we went to subscription is because we're enhancing that. I'm making it better. Trust me.
Right.
We're going to be giving you more stuff. We're going to actually bring the residential program to life. Okay. We're going to be bringing the grounding and bonding stuff. I'm going to be doing that and bringing it to life. This was a move to better education. Okay. We are getting away from where the stuff is free, but it's not expensive. If I give you over 700 videos and 700 podcasts and all you pay is a $9.99 a month that you can cancel at any time, if you want to go in and binge watch it for the month, you're paying one fee. That's it.
Yeah.
So this is for a move that allows me to control and stop giving away money to YouTube and stop giving away money to Google and all those places y'all know that I hate. I know they're you got to use them, but they're still, to me, evil. So that's why I created the Sparky Hub. That's why we do everything through our website so that we can get directly. Now, will I take advantage of YouTube? Absolutely. YouTube, you're watching. I will use you to store videos. I will use you to store podcasts. So to me, I think smarter. I like to work smarter, not harder. People pay a lot of money for online storage. I use YouTube because it's free and it's unlimited. And I can store unlimited amounts of videos, unlimited amounts of podcasts, and it costs me nothing. That way I can pass this on to you. So we're going to be able to do things with this program. We're going to be able to have contests. We're going to be able to give away subscriptions. We're going to be able to do a bunch of things moving forward that I can't tell you everything. But this was a good move. Okay. So, that type of thing. Yeah. On Facebook, it says chess because you usually have to pick a game that you're playing. So I always like to pick chess or battle chess or, maybe next time I'll pick Pac-Man or something. But anyway, that's over on our YouTube stream. So, Jay, is anything else that you want to give tonight? We'll have more information on what's going on, and pay attention to our YouTube channel and everything. Hopefully you subscribe. At least you'll get notifications. But we will slowly move away. Okay, move away from that. Jay, your camera's just flickering like a crazy dog.
Oh anyway, my goodness!
So, anything you want to give to? Oh, look, he's gone with the thumb palm right into the camera. Anything that you want to give out to anybody or shout outs until we call this one a night?
No, I just appreciate everybody coming on tonight and hanging out with us. Hopefully you learned something on the terminal limitations.
Yeah.
If you do have any questions, if you guys have any code turds that you guys see out in the field, hit us up at host@electricianlive.com. I put it in the chat feed on the YouTube channel, but again, it's host@electricianlive.com.
Absolutely.
We'd love to hear from you guys, see photos from you guys, and just be able to praise you as well as the viewers, man. We couldn't do it without you. We really do appreciate you guys, and make sure you go subscribe and become a part of that exclusive membership that we have to offer.
Yep. All right, guys. Well, as always, stay safe, work hard, God bless, and we will see you next week on Electrician Live.
You're listening to Electrician Live with your host, Paul Abernathy and Jay Grunberg.